Hello everyone, welcome to ACE Engineering College YouTube live session. Myself Dr. Prem Kumar, faculty of ACE Engineering College. I am going to discuss software engineering subject. One of the concept which we are going to discuss in today's session is conceptual model of the UML, and we are going to discuss what are the various relationships in UML, what are the various types of UML diagrams which we will discuss in detail. Conceptual model of the UML. First of all, what is UML? UML stands for Unified Modeling Language. UML stands for Unified Modeling Language. What is the importance of this UML, Unified Modeling Language? UML is one of the object-oriented modeling language. If any designers, if they want to design a software system, they need one of the modeling language, that is one of the modeling language, that is UML. Why UML became popular? Because as a designer, if you want to design the object-oriented software system, then UML is the best suitable modeling language to model any object-oriented software system. So why this UML became popular? Because any software system which can be modeled in the form of objects and classes. So the size of the object and class is very small, so that the designers, they can easily design, they can, the developers, they can easily develop it, that can be easily testable, replaceable, reusable. That's the advantage with object-oriented modeling language. Before UML, what might be the modeling, how the software designers, they are going to model the software system. Before existence of UML, DFDs were existed. Before UML, DFDs were there to model the software system. DFD stands for data flow diagram. So what is the problem with this data flow diagram? So when the designers, they are using DFDs to model a software system, when the complexity of the software system is increased by using DFD, the DFD, when the designers, they are using DFDs to model a software system, when the size of the software system is increasing, then complexity of the software system is increased by using DFD. To resolve that problem, UML was introduced, Unified Modeling Language was introduced, which is one of the object-oriented modeling language. So to better understand the UML, then to build the conceptual model of the UML, three things supposed to be better understandable here. UML, which consists of building blocks, we call them as UML building blocks. UML building blocks. UML consists of three building blocks. What are those three building blocks? First one is of things. Second one is of relationships. Third one is of diagrams. UML building blocks were classified into three categories. First one is of things, second one is of relationships, third one is of diagrams. Using these three building blocks, the designers, they can design a software system. That's why UML building blocks plays major role to model a software system. About these three building blocks, we will discuss in detail. Again, these UML things were classified into four categories. Things were classified into four categories. What are those four categories? That we'll discuss. Things were classified into four categories. First one is of structural things. Second one is of behavioral things. Third one is of grouping things. Fourth one is of annotational things. So UML things were classified into four categories. Those are, first one is of structural things, second one is of behavioral things, third one is of grouping things, and fourth one is of annotational things. About these things in UML, we'll discuss in detail. First one, structural things. So what is the importance of structural things? Structural things were used to model the static view of a software system. So if any other stakeholders, if they want to know the model of the software system, static part of the software system, through structural things, they can view the static part of the software system. That is what the purpose of modeling structural things. Coming to behavioral things purpose. Behavioral things were used for modeling the dynamic view of a software system. So other stakeholders, if they want to understand the dynamic view of a software system, through behavioral things, they can understand it. That is what the purpose of behavioral things. Coming to grouping things. So grouping things. So collection of UML elements will be grouped. So that is what the purpose of grouping things. So grouping things which consists of classes, objects, interfaces which can be stored in this particular grouping things. Coming to annotational things, the purpose of annotational things here is, if any designers, if they want to describe about their model, if they want to describe about one of the UML element using annotational things, they can attach comment, description about that particular model, so that other stakeholders, other designers, they can easily understand. So that is what the importance of annotational things. We'll discuss here about structural things. We'll discuss about structural things. Structural things. Structural things in UML. So what are the things which comes under structural things? First purpose of structural things which is used to model the static view of a software system. So what is the example here is class comes under one of the structural thing. Interface is a structural thing, right? Use case comes under structural thing, right? Class, interface, use case, component comes under structural thing, right? Node comes under structural things. These are all the structural things, means which represents the static view of a software system, which represents the static view of a software system. So what is class represents here? Group of similar objects which can form a class. Group of similar objects which can exhibit here what? Here class. What is the graphical representation of class in UML? So graphical representation of class in UML can be represented with a rectangle box, which can be represented with a rectangle box. Right? Class. Any class consists of three compartments: class name, attributes, and operations. So group of similar objects can form a class. Graphical representation of class in UML, rectangle box which consists of three compartments: class name, attributes, and operations. Coming to interface, what is interface here? Set of operations. Set of operations which can be specified for individual classes. Means one class wants to communicate with another class, interfaces can help. Interfaces can establish it. Interfaces can connect between two classes, and the information can be passed from one class to another class. So that is what interface represents, set of operations which can be performed by various classes or components, right? Coming to use case. What is use case? Set of operations which are performed by a software system, we call it as use case. Any software system. This is what ellipse represents here, use case. So any software system is a collection of use case. That means to say set of operations which can be performed by this particular software system. So that is what here use case. Coming to component. What is component? Physical replaceable part of a software system, we call it as components. Executables, files, is it? Libraries, is it? All those comes under components. What is the graphical representation of component in UML? This is what graphical representation of component. Physical replaceable part of a software system, we call it as component, right? And coming to node, what is node? Node represents here standalone computer. So node represents what here? Standalone computer. So what exactly the graphical representation of node in UML? Cubic, right? This is what node means. That means to say server machine or server system, right? So node represents here hardware configuration of a server system, right? So which is having here what hardware resources, is it? On this particular hardware resources, CPU, memory, storage and all, is it? Which you can deploy the component. That is what the importance of node. So this is what structural things which represents the static part of a software system. When designers, they want to model the static view of a software system, all these things supposed to be modeled here. Class of that particular software application, interfaces required and use cases required, component, node, hardware configuration to store all the software components in it. So that is what one of the things, that is structural things in UML. Then what is the second one here? Behavioral things in UML. Behavioral things in UML. What is the purpose of behavioral things in UML? Behavioral things were used for modeling the dynamic view of a software system. Behavioral things were used for modeling what? Dynamic view of a software system, right? Any stakeholders, if they want to know the dynamic view of software system using behavioral things, right, they can view the dynamic view of a software system. So what are the things which comes under behavioral things here? So the things interactions among objects, right? Dispatching of messages among objects, all this comes under interactions. And state mission, so behavioral things, state mission also, state mission. So state mission, which consists of various states, when some event has occurred on that particular state, that behavior is changing from one state to another state. Let's say this is what, right, consists of state 1, right, state 2, right, here is state 3, reaching to final state. So here one object which was at initial state, when some event has occurred, which moved to state 1. When some event has occurred, the object is at state 1. When some event has occurred at state 1, that's it, some operation has performed, some condition was satisfied, that's why transition is triggered from state 1 to state 2. Now the object at state 2, again here some event has occurred, because of occurrences of event, some operation has performed, means condition has satisfied. That's why transition is triggered from state 2 to state 3. Again at state 3, some event has occurred, because of occurrences of event, some condition has satisfied, some operation has performed. That's why transition is triggered from state 3 to which state here? Final state. So this is what state mission. So the behavior is changing from one state to another state. The single object which is moving from state 1 to state 2, state 2 to state 3, reaching to final state. So that is what behavioral things. So behavioral things which were used to model the behavior of the software system, how the software behavior is changing from one state to another state. So that is what behavioral things in UML. Coming to third one, grouping things in UML. Grouping things in UML. So what are the various grouping things here? So grouping things, the purpose of grouping things here is the UML elements, classes, interfaces, components, all these supposed to be stored, that is in form of what we call it as package. Package. What is a graphical representation of package? Graphical representation of package. This is what we call it as package. So what this package stores here? All these classes will be stored in this package. Right. Right. Package. This we call it as package. What it store here is, what are the classes, interfaces, components, all those things will be stored, grouped in this, in this package. That is what the importance of grouping things, right? So coming to next, annotational things. What is the importance of annotational things? Importance of annotational things in UML. Annotational things importance here is, the designers, they have designed the software system, right, which is collection of various elements of that particular software system. That model, the designed model is supposed to be given a description about that particular model that can be represented, that is by using these annotational things. So that we call it as note. So note can be attached to each and every element of UML, so that description about that model, description about that each and every model can be given, that is in the form of note. So that is what the importance of note. So what is the graphical representation of note? This is what graphical representation of note. So that means to say here, comment about the model can be attached by using this note. That is what the importance of annotational things in UML. Annotational things in UML. So these are, we call them as things. UML things were classified into 4 categories: structural things, behavioral things, grouping things, and annotational things we have discussed so far. Coming to next, what are the various relationships in UML that we'll discuss. So second building blocks of UML. UML building blocks were classified into 3 things: relationships and diagrams. So we are going to discuss second building block, that is relationships in UML. So relationships in UML were classified into 4 categories, 4 types of relationships in UML. 4 types of relationships. 4 types of relationships in UML. What are those 4 types of relationships in UML? First relationship in UML is dependency. Dependency relationship. Second one is of association relationship. Third one is of generalization relationship. Fourth one is of realization relationship. These relationships plays major role while modeling a software system. Relationships in UML can establish connections among UML elements. That's why relationships in UML plays major role. So relationships in UML were classified into 4 types. First one is of dependency, second one is of association, third one is of generalization, fourth one is of realization. We'll discuss about these 4 relationships one by one. First one is of dependency. What is the importance of dependency? Dependency is a relationship where one class can depend on another class. What are the changes which we are doing in another class which can reflect on that particular class? So that is what the importance of dependency relationship. What is a graphical representation of dependency in UML? This is what graphical representation of dependency in UML. Graphical representation of dependency in UML, right? Now observe, let's take, there are 2 classes. Class 1, right? Attributes, operations. Here is one more class. Class 2, attributes and operations. These are 2 classes, right? What is the situation where dependency relationship should be used while modeling the classes for the software system, right? When class 1 is depending on class 2, class 1 is depending on class 2. In this situation, only dependency relationship should be used between these 2 classes. When class 1 is depending on class 2, in that situation only we have to use dependency relationship, right? What are the changes which has done at class 2 that will be reflected on class 1? So that is what the importance of dependency relationship. When the designers, they are designing a software system, right? If they want to establish dependencies among classes or components, then they have to use this dependency relationship. Dependency is a relationship where one class is depending on another class. In that situation only, as a designer, you have to use dependency relationship. That is what the importance of dependency, right? and association relationship. So what is the importance of association relationship in UML? So here association relationship which can establish links between two classes or among multiple classes. So that is what here association relationship. What is the graphical representation of association in UML? This is what graphical representation of association. And here association can be represented here, association navigation, arrow also. We call it as what here? Association navigation. Association navigation, right? So this is what the importance of association relationship. What is the situation where we have to use association relationship? When two classes were depending on each other, in that situation only we have to use association relationship. When two classes were depending on each other, in that situation only we have to use association relationship. We have to use association relationship, right? So here in the previous case dependency, only one class is depending on another class, that's it, but another class is not depending on that class. So here, whereas in association relationship, when two classes were depending on each other, in that case only we have to use association relationship. Let me take simple example here. So here employer is one class, employer is one class, employer attributes operations which you can add. Employee is one more class here, employee is of one more class. You can add attributes and operations. These are two classes. As a designers, you want to model these two classes and you want to establish relationship between these two classes. Among these four relationships, which relationship is best suitable here? Employer is one class, employee is one more class. These are two different classes. That's it. What is the best suitable relationship which we have to apply as a designer? If you apply wrong relationship as a designer, we had done here design flaw, some design error which was committed by the designer. That's why designer has to think properly. What is the best suitable relationship between these two classes? As a designer, we have to think and we have to establish proper relationship. Employer is one class, employee is one more class. That's it. Employer is a what here class depending on employee class. At the same time, employee class also depending on employer class. That means you would say two-way dependency. What is the relationship which is suitable here? Association. So which is a two-way dependency. Employer class is depending on employee. At the same time, employee also depending on employer. That's why association relationship is best suitable to model this particular class, this particular software system, right? The software, simple software system which consists of employer and employee class, two classes. So what is the best suitable relationship required here? Association. That is what the situation where as a designer you have to use association relationship if you want to model such systems, right? Coming to next, third relationship in UML, that is generalization. What is the importance of generalization? As a designer, when you want to design parent and child class, as a designer, whenever you are trying for modeling what superclass and subclass, is it as a designers, when you are trying for modeling the base class and derived class, in that situation you have to use generalization relationship. So that is simply we call it as, if you want to model inheritance concept while modeling object oriented software system, you want to model the inheritance concept, that means to say parent and child class. In that situation only you have to use generalization relationship. So what is the graphical representation of generalization here? Graphical representation of generalization in UML. This is what graphical representation of generalization in UML. Graphical representation of generalization in UML. So why UML became popular? UML is one of the object-oriented modeling language. As a designer, if you want to model a software system, that's it. Using UML, you can model the software system that is in the form of a diagrammatic representation, graphical representation, so that anybody can easily understand the design model of the software system. That's why UML became popular. That's why software industries, they are using UML to design the software system. That's what the importance of UML, right? So generalization, graphical representation of generalization in UML is this, right? Now the point here is, what is the situation where we have to use generalization here? When we want to model parent and child classes, in that situation only we have to use generalization relationship, right? So let's say here, gas consumer is a class. Let's take which class? Gas consumer is a class. Gas consumer, right? And here there are two other classes. What are those is commercial gas consumer, commercial gas consumer, right? One more class is of individual gas consumer, individual gas consumer. So how many classes we have here? Just three classes we just identified. What are those here is gas consumer is a class. As a designer, whenever you are trying for designing the online gas booking system or online gas system, in that case you are supposed to identify what are the classes for online gas booking system. Let's take in our case we identified three classes. Gas consumer is one class, is it? Commercial gas consumer one more class, individual gas consumer is one more class. So these are three classes as a designer we identified. What is the best suitable relationship among these three classes? As a designer we have to think and we have to apply suitable relationship among these three classes, right? So now observe carefully which class might be the parent class, which class might be the child class here. Gas consumer is a parent class, right, or super class. And what are the here child classes? These two we call them as child classes, right? So if you want to establish, if you want to model parent and child classes, in that situation only we have to use generalization relationship. In that situation only we have to use generalization relationship. That's why generalization became popular, is it? When we want to model parent and child classes, is it? Then in that situation we have to use generalization relationship. What are the properties of this generalization? So child can be substitutable by parent, can act as a parent, can communicate with other classes. Child can acquire the properties from the parent class. So those are the properties of what here? Generalization. Properties of generalization. So that is what third relationship in UML. Coming to fourth relationship in UML, realization. So what is the graphical representation of realization? Graphical representation of realization. This is what graphical representation of realization. Graphical representation of realization. What is the situation where we have to use realization relationship in UML? That which we need to discuss here, right? So there are two classes, and one class wants to assign some responsibility to another class has to implement that responsibility. In that situation only we have to use realization relationship. Let's take here, there are two classes, right? Class 1, class name simply. Class 1, this is class name, attributes, we can add, operations we can add. One more class, class 2, class 2, we can add attributes as well as operations, right? When class 1 wants to assign some responsibility to class 2 has to implement it. In that situation only, we have to use realization relationship. In this situation only we have to use realization relationship. That is what the purpose of realization relationship, right? So very frequently while modeling software system, most frequently used relationships are of three: dependency, association, and generalization. So realization relationship can be used very rare. That is what the importance of relationships in UML, which plays major role while modeling a software system, right? Coming to next, we are going to discuss about UML diagrams. What are the various types of diagrams in UML? How many types of UML diagrams are there? So there are 9 types of diagrams. There are 9 types of UML diagrams. There are 9 types of UML diagrams, which are classified into 2 categories, which are classified into 2 categories. What are those 2 categories? Let's identify. So UML diagrams are of 9 types. Those are classified into 2 categories. First one is of structural diagrams. structural diagrams. Second one is of behavioral diagrams. Behavioral diagrams. Structural diagrams, behavioral diagrams. What are the diagrams which comes under structural diagrams? What are the diagrams which comes under behavioral diagrams? Let us identify what are the structural diagrams. Structural diagrams are of here class diagram, right? Object diagram, component diagram, deployment diagram, deployment diagram. Coming to behavioral diagrams, sequence diagram, collaboration diagram, collaboration diagram, use case diagram, state chart diagram, and an activity diagram. UML diagrams were classified into how many categories here? Two categories, structural diagrams, behavioral diagrams. As a designer, if you want to design any software system, you have to design all these 9 kinds of diagrams so that you can say that you designed the what software system? You designed the software system. So UML diagrams were classified into 2 categories, structural diagrams, behavioral diagrams. What is the purpose of structural diagram? Briefly we had discussed, which were used to model the static view of a software system, which were used to model the static part of a software system. Coming to behavioral diagrams, which were used to model the dynamic part of a software system. As a designer, if you want to design the dynamic part of a software system using these behavioral diagrams, which you can model the dynamic part of a software system, right? So what are the diagrams which comes under structural diagrams here? Class diagram, object diagram, class diagram, object diagram, component diagram, deployment diagram. What are the diagrams which comes under behavioral diagram? Sequence diagram, collaboration diagram, use case diagram, state chart diagram, and activity diagram, right? So about these diagrams, briefly we will discuss, then later we will take one case study and we will model what here? What is the class diagram for that particular application? What are the component? What is the component diagram, deployment, sequence, collaboration, use case, state chart, and activity diagram? That we will discuss it anyhow, right? So what's the importance of this class diagram? Class diagrams were used for modeling the static view of a software system, right? So that is what the importance of class diagram, right? Then what is the purpose of here? Object diagram. If you want to model the object of software system, so collection of objects, if you want to model the collection of objects of the software system, using object diagram can be modeled. And if you want to model the physical aspect of a software system, there exactly component diagrams required for us. And if you want to model the hardware configuration of a software system, there exactly deployment diagrams required for us. Hardware configuration, deployment diagram purpose here is which represents the hardware configuration of a software system, right? The software system which is going to run, is it on which hardware configuration? That hardware configuration of that particular software application can be modeled by using this deployment diagram. That is for the purpose. About this we will discuss in detail anyhow, right? Coming to sequence diagram, behavioral diagrams, under behavioral sequence diagram. Sequence diagrams were used for modeling the dynamic view of a software system. How the group of objects, they are dispatching messages among them, how the message dispatching is taken place and all, we will discuss and we will draw the diagram also, right? Coming to collaboration diagram. Collaboration diagram, which is used to model the dynamic view of a software system. How the structural organization of objects can be modeled. So using collaboration diagram, structural organization of objects modeling will take place. Coming to use case diagram. The purpose of use case diagram is which is used to model the functional requirements of a software system. So what exactly the user is expecting from the software system? What are the services the user expecting from the software system? That can be modeled, that is in the form of use case diagram. So through use case diagram, functional requirements of the software system can be modeled so that the designers, they can easily understand it. That's it. So that is what the purpose of use case diagram. Coming to state chart diagram. The purpose of state chart diagram is, which is used to model the behavior of the individual objects. How to model the behavior of the individual objects, that we'll see by using state chart diagram. Then which such diagram can model the behavior of the multiple objects? Sequence diagram is a diagram which is used to model the behavior of the multiple objects, right? Coming to activity diagram, which is used to model the how the activities were flowing. And whenever we have parallel activities, so parallel activities, concurrent activities can be modeled by using this activity diagram. That is what the purpose of activity diagram, right? So about these diagrams, we'll discuss in detail with one case study. So how to model, is it, all these UML diagrams by using one of the application, that is ATM application. So that we'll discuss, right? So before that, we'll discuss few concepts. So basic structural modeling. So structural modeling, through which you can understand the structure of the system and draw a structural model like a class diagram. And here we'll discuss about the class diagram. Modeling means, what is meant by modeling here? Means creating diagram for a system. What is modeling represents here? Creating diagram for a system. That includes identifying the elements that are important to your particular module. The structural modeling gives a structural view of a system that highlights the structure of the objects, including their classifiers, relationships, attributes, and operations. So we already discussed graphical representation of class, rectangle box, which consists of 3 compartments: class name, attributes, and operations. Let's see the diagrammatic representation, right? Class. This is what a rectangle box. So graphical representation of class in UML. Rectangle box, which consists of 3 compartments: class name, attributes, operations. Class name, right? Attributes here, we can add attributes. For example, ATM user is a class. What are the attributes? Name of the ATM user, is it? Mobile number, address, and all those things. What are the operations ATM user can perform here? So withdraw, deposit, check, balance, all this. But anyhow, we'll take one example, we'll discuss later, right? And coming to class attributes and visibility. So we had discussed car is a class. So any class consists of 3 compartments: class name, attributes, operations. So car is a class. Attributes here is maker name. So string here. Wheel size integer, right? Gears integer. Frame size integer. Color string. What are the operations here? Repair and move. Class name, attributes, operations. Now here class attributes and visibility. What is meant by usability? Visibility here. Place. So publicly accessible class. This class can be accessible by anybody, any general user. That is what public visibility we call it as, right? And coming to this, we have discussed briefly about the 4 relationships in UML, right? So this is what, just observe here how many classes we have. Vehicle is one class. What is the class name here? Vehicle is a class. What are the attributes? We can add some attributes for vehicle. That's it. Operations, repair and move, right? Coming to body shape, body shop is one class. We can add attributes, operations. Here vehicle class, is it? Here one more car is class, bus is one more class, driver is one more class. What are the relations supposed to be established among these classes? So as a designer, initially you have to identify classes, later you have to establish suitable relationships among class, so that you design the complete software system. You model the complete software system, right? Before going to model a software system, first and foremost thing, you have to identify what are the classes for your software application. Then later you have to apply suitable relationship. Just observe these 2 classes, vehicle class and body shop class, right? So what is the relationship here? Dependency. Vehicle is depending on this particular body shop class. That's why dependency relationship was used between these 2 classes, right? Now observe these 3 classes, only just these 3 classes. Vehicle, car, and bus. Among these 3 classes, which class is a parent class, which class is child class here? Vehicle is a parent class. Which class? Vehicle is a parent class, whereas car and bus, these 2 are child classes. Child classes, right? These are two are child classes. Then what is the best suitable relationship between these two classes here? So parent, if you want to model parent and child relationship by using UML, you have to use generalization relationship. This is what generalization relationship, parent and child classes were modeled here. Now observe carefully again these two classes, bus class and driver class, these two classes, bus and driver. So which relationship is best suitable between these two classes here? Which relationship is best suitable between these two classes? Just observe here, bus, driver. Bus is depending on driver, at the same time driver also depending on bus. That's why which relationship is best suitable here? Association, two-way dependency. Both were depending on each other. Bus is depending on driver, at the same time driver also depending on bus. That's why as a designer we had used association relationship, two-way dependency relationship. The name is association, right? So this is about different relationships, dependency, generalization and association, right? Coming to next, in association between two classes, let's take here school is one class, university one more class, right? So multiplicity, how many schools under university? Multiple schools can be established under university. So one and so on star means multiple schools which belongs to one university. So works for, association name, works for, right? So here employee, so and employer, university. So which relationship we had used here? Association. Why association? Schools were depending on university, at the same time university also depending on schools. That's why two-way dependency, that's why association relationship was used between these two classes, right? So what is the role here? Employee, employer is the role, right? Coming to common mechanisms. So while modeling software system, as a designer you need some common mechanisms which you're supposed to use these common mechanisms while modeling a software system, right? So what are those common mechanisms? Note. So we already discussed one of the things were classified into four categories, right? Structural things, behavioral things, grouping things, annotational things. Annotational things can be represented by using note. So what is a graphical representation of note? This is what graphical representation of note. Graphical representation of note, right? So what is the purpose of this note? We are discussed, right? So if you want to describe, if you want to give comment about this particular software system model, this is what software system model, right? For this model, if you want to give some comment, description about this model, then we are going to use this note. That is what the purpose of note, giving comment about that particular model so that other designers, they can easily understand what exactly that model, how the model was, exactly the model is talking about. So description about that particular model can be given by using this note. So which we call it as common mechanisms. A note is a graphical symbol for rendering constraints or comments, simply comments, right? Attached to an element or a collection of elements, just know what we had discussed, right? And even we can use stereotypes also. What's the purpose of stereotype? A stereotype is an extension of the vocabulary of the UML, Unified Modeling Language, allowing you to create new kinds of building blocks similar to existing ones but specific to your problem, right? Tagged values. What is the importance of tagged values? That we'll discuss here. A tagged value is a property of a stereotype. So allowing you to create new information in an element bearing that stereotype. Just see here graphically how to represent tagged value, we'll see. And constraint, we know what is meant by constraint. Constraint is nothing but condition. Under which condition the model is supposed to be built, supposed to be designed. So that can be represented with constraint, right? So stereotype, this is what here, named stereotype. So accounting, this is what stereotype graphical representation, right? And this is what named stereotype with icon. So named stereotype exception, underflow, right? And with icon, right? And here this is one more named stereotype with icon. This is also, what is that? Humidity sensor can be represented like this. Tagged values, just now we had discussed. So what is here tagged value here? Required capacity, server machine. What is the capacity of the server machine? Required capacity. So that can be represented in integer value, is it? So capacity of the server machine might be 1 terabyte. Is it 1 terabyte out of 500 gigabyte, right? So that is a capacity, integer value, 500 means, is it? So that is what here, what we call it as tagged value, which represents some capacity, right? And coming to constraint, constraint is nothing but condition. Under which condition? The model is supposed to be built. So conditions, so constraint is nothing but condition, right? Here portfolio, bank account. So bank account can be given to corporate and to person, gender male or female, under which condition? Object constraint language. OCL stands for what here? OCL stands for object constraint language. Object constraint language. OCL stands for object constraint language. So self dot wife dot gender female. This is what the constraint condition. Then only what will be given here? Account can be opened. What self dot husband dot gender is male. So these are the constraints condition. Under these conditions only account will be given by the bank, right? And common mechanisms. So as a designer, while designing a software system, which you can use common mechanisms, some common methods here, right? So IGNOU, this is what class name, attributes, operations, which you can, description. This is what here, note. Note is nothing but description, describing about this particular class, right? Giving more details about this particular class. Who needs the details about individual elements of UML here? Other designers, other stakeholders. If they want to understand your model better, then with the help of this note, so they can better understand your model. That is what the purpose, right? And here also, so course is a class, attributes, course code, course name, operations, add course, remove course. This is what named stereotype. This is what here constraint. Under which constraint? Oh, what is the constraint to model such classes here, right? Allow only one course for a student. So one student should take only one course. That is the constraint. Based on this condition only, this particular software system is supposed to be modeled. Course registration system supposed to be modeled. So information, describing, notations. Next, we are going to discuss about class diagram, right? So what is the importance of class diagram? Class diagrams were used for modeling the static view of a software system. Class diagrams were used for modeling the static view of a software system. Let's take class diagram for student registration, right? So school is one class, department is one more class, right? Student one more class, course one more class, instructor one more class. These are the classes. How to establish relationship among this class? So this particular class diagram, which is used for modeling the student registration system. The student, they are supposed to register for the course. That's it. That is what the purpose. Let's see here. So which one is the large or complete class? School is a complete large class. School class can have attributes, operations. It's fine, right? And student is one more class. Is the student part of the school or school part of the student? That's a question here. That is a question, right? Is the school part of the student or student part of the school? So definitely student is part of the school. That's why this relationship was used in UML. We call it as aggregation relationship. What is the situation where we have to use aggregation relationship? When we are trying for modeling the small part of a class from the complete class, in that situation only we have to use aggregation relationship. So student is small part from the school class. That's why we had used here aggregation relationship between school class and student class, between school class and student class. That is what the importance of aggregation relationship. That's the importance of aggregation relationship. Now observe again, we had considered these two classes, and why we had used here aggregation relationship we identified. Consider these two classes, school, department. Is school part of the department or department part of the school? That's a question here. So which one part of which? Which one is larger class, which one is smaller class? Is school part of the department or department part of the school? Definitely department is part of the school. Department has, so multiple departments can form a school. That means to say, small part of department from the school, if you want to represent, we have to use which relationship here? There is a name here. This is aggregation. This is also similar like aggregation, but there is a name for this. We call it as composition relationship. We call it as which relationship here? Composition relationship, which is like aggregation. But the difference between aggregation and composition we have to observe, right? Which one is stronger? So department is stronger, to school, is it? So without department, schools cannot exist. And here school and student, we had used aggregation. So here not that much of stronger. That's what the point here. That means to say I'll give one example. I'll give one example here. For human body, one of the human body, if fingers of the person were removed, is there any problem? That person can, is it alive? Is it that person can alive and they can do as usual, right? No, there is no much problem. Is it? For the same person, if heart was removed, will that person alive? No. So which one is stronger here? Which one is stronger for the person? The heart is it more required part, stronger part than the fingers of that particular person. Similar way here also. Department is like a heart for the school, whereas student like a fingers. That's why between school and department, what relationship is best suitable here? Composition relationship in UML is stronger than aggregation relationship. So that is what, as a designer, while designing we have to think which relationship is best suitable among classes. That we have to think, and that we have to specify, that we have to use best suitable relationship among classes. Then only our design model is what valid design model. Otherwise, which might have some design flaw, means design errors, right? That's why designers has to think properly and has to establish, specify suitable relationship among classes, right? Coming to department and course, what is the best suitable relationship here? Association. Course depends on department, department also depends on course. So two-way dependency. And between student and course, student depends on course, course also depends on students, so association relationship. Coming to instructor and department. So instructors were part of department. That's why which relationship was used here? Aggregation relationship which was used. Aggregation relationship was used. Right? Again, department and instructors, two-way dependency. Department belongs to, depends on instructor, at the same time instructors also depends on department. So this is what, how to model what student registration, the student registration system. So class diagram for student registration system. So this is what, one example, right? Next we are going to discuss use case diagram. So how to model use case diagram for one of the case study. So that is how to model use case diagram for ATM application, that we will discuss, right? So we have discussed it briefly. What is the purpose of use case diagram? What is the need of use case diagram? Use case diagrams were used for modeling the dynamic view of a software system, right? Use case diagrams which represents the functional requirements of a software system. As a designers, if you want to know the functional requirements of a software system, then we can represent the functional requirements of the software system using use case diagram. So use case diagram which describes the functional requirements of a software system. What exactly the client is expecting from the software system, that can be represented by using use case diagram, right? So a use case diagram describes how a system interacts with outside actors. It is a graphical representation of the interaction among the elements. Each use case represents a piece of functionality. Let's see here. So any use case diagram which consists of set of use cases, actors, relationships among actors and use cases. This is what any use case diagram which consists of, right? So what is the use case? Ellipse. This is what? Withdraw money, withdraw. That is one use case. One operation can be performed. What is actor? The user who is going to interact with the software system. Actor is nothing but user. Relationship. So among actors and use cases, which relationship is best suitable? There are 4 relationships in UML, right? So that is what description here, right? And coming to use case diagram, right? So we'll discuss use case diagram in detail. Use case diagram contains 4 components. Just now we have discussed the boundary of the software system and the actors. Just now we have discussed means user, ATM user, simply we call them as and here relationship between among actors and use cases, right? About this use case diagram, we will discuss with the help of one case study. Draw a use case diagram. Draw a use case diagram for ATM application. For ATM application. Draw a use case diagram for ATM application, right? So how to model use case diagram for ATM application? Before going to model use case diagram for ATM application, first of all, we have to perform analysis. Means what are the, any use case diagram is a collection of use cases, set of use cases, set of actors, relationships among use cases and actors. So first and foremost thing, before going to model use case diagram for ATM application, first you have to identify what here? Identify set of actors, right? Set of use cases means operations performed by each and every actors. Relationships among actors and whom here? Use cases. This is what as a designer has to perform this analysis, and designers has to identify set of actors and corresponding use cases and suitable relationships supposed to be established among actors and use cases. So we are trying here modeling the use case diagram for an ATM application. What might be the actors for the ATM application? ATM user. So graphical representation of actor in UML. This is what graphical representation of actor, right? User is, ATM user is one of the actor, right? Who might be the one more actor here? So we are talking about ATM application, banking application. So manager might be one of the actor, right? And if the banking system, right, if it is giving any kind of problem, who is the troubleshooter here? So administrator might be one more actor, administrator. Administrator is of one more actor. So for the ATM application, we are modeling use case diagram. Initially, as a designer, you have to identify what might be the actors. Next, what might be the operations where each and every actor can perform, that we call it as use case. What is use case? Set of sequences of operations which are performed by a system. So as a system or user or a device, right? Here in our case here, actors, they can perform some operations. What might be the operations a user can perform here? So user can perform here some operations here. What are those here is, this is what use case, request for ATM card, request for ATM card. So user is requesting for ATM card. User can perform which operation? Withdraw money. Is it? Withdraw money, right? User can perform change password. Password can be changed by the user, right? Users can perform. If user is getting any problem, right? Asks for clarification of problem. Asks for clarification of problem. Some operations. You can add n number of operations. You are the ATM user. What are the other operations? Log in, log out. You can add n number of operations. It all depends upon the user's choice, right? How better software system which you are going to design, right? So these are all the operations where user is going to perform. Coming to manager. What are the operations where manager can perform? What are the operations when manager can perform? Manager also can perform various operations. What are those various operations where manager can perform? That we'll see here. So manager can perform various operations. Let's see what are the operations where manager can perform here. That we'll see, right? So manager can perform issue ATM card, can be issued by the manager, ATM card, right? Create account. Manager can create account of new account holders, right? What are the other operations where manager can do here? Informs newly issued card details, These are all the operations where manager can perform, right? These are all the operations where manager can perform, right? Coming to administrator, what are the operations where administrator can perform? So administrator can perform here, solves user problems, solves user problems, right? So which relationship is suitable between these two? So ask for clarification of problem can be solved by administrator. So as a user, ATM user, you tried your, initially you inserted your card for withdraw of money, you entered wrong PIN number. Again, second time you inserted, you entered wrong PIN number. Third time you inserted, you entered wrong PIN number. What will happen fourth time? Your card was blocked. Who is going to unblock your card here? Administrator. So administrator unblock card. Administrator going to unblock card here. What are the other operations where administrator can create profile of each account holder. Create profile of each account holder, right? And confirms newly issued card details. Confirms newly issued card details. These are all the operations where administrator can perform here. So among these here, so create profile. So this use case can depend on confirms newly issued card details, which is depending on which use case here, informs newly issued card details. So this is what use case diagram for an ATM application. User is one of the actor, manager one more actor, right? Administrator is one more actor. So what are the operations user can perform here? User can perform here, change password, request for ATM card, withdraw money, right? Ask for clarification of problem. Those are the operations where user can perform. Coming to manager, what are the operations manager can perform here? Issue ATM card to the users, create account, informs newly issued card details. Those are the operations where manager can perform. What are the operations where administrator can perform here? Administrator can perform here, solve user problems. What are the problems which were raised by the user? Is it the administrator can perform. So here the two use cases were depending on each other here. That's why dependency relationship was used. Ask for clarification of problem is what use case belongs to user, which is depending on the use case which belongs to administrator. That's why dependency relationship is what's used here, right? So coming to what are the other operations where administrator can perform here? So unblock card, unblock cards, ATM cards, right? Create profile of each account holder, right? That is one more operations which can be performed by whom here? Administrator. Confirms newly issued card details. This use case also belongs to whom here? Administrator. That's it. And here, now observe, this use case, administrator use case, confirms newly issued card details, which is depending on the use case belongs to manager, informs newly issued card details. So this is what use case diagram for an ATM application, right? What is the purpose of this use case diagram? The main purpose of the use case diagram is to capture the dynamic aspects of a system. Use case diagram shows what software is supposed to do from user's point of view, right? So, and when to use case diagram? What is the situation where we have to use case diagram? Use cases are used in almost every project. They are helpful in exposing requirements and planning the project. During the initial stage of a project, most use cases should be defined. Coming to class diagram. What is the importance of class diagram? Class diagrams were used for modeling the static view of a software system. Class diagrams were used for modeling the static view of a software system, right? So that is what about introduction about class diagram, static view of a software system which can be modeled by using class diagram. So about this class diagram, that's it. How to model class diagram for an ATM application, that we'll see now, right? So draw a class diagram for an ATM application. Draw a class diagram for an ATM application, right? So as a designer, before going to model class diagram for an ATM application, what you supposed to do here? First, you have to identify set of classes for an ATM application. Identify set of classes, right? After that, what you have to do? Add attributes and operations for that particular class. Establish relationships among classes, relationships among classes. For ATM application, we are going to model class diagram for an ATM application. So any class diagram is a collection of classes, was it, and relationships among classes. For ATM application, what might be the classes here? Let's take here, for ATM application, what might be the classes here? Just observe, for ATM application, which consists of various classes, right? What are those here is? User is one class, ATM user. ATM user is class, is it? So what are the attributes for the ATM user class here? User, ATM user name, address, age, right? What are the operations where ATM user can perform here? So here operations, add customer, these are the operations, update customer details, delete customer details, right? So that is user, is it? And here for ATM application, the user, is it, bank is one more class. What is one more class here? Bank is of one more class, right? So what are the attributes for bank class here? Name of the bank, place of the bank, address of the bank, is it? What are the operations bank class here? Through bank class can perform here. Withdraw money, deposit money, right? So these are two classes. What is the best suitable relationship between these two classes? So user is one of the class, bank is one more class. So user can depend on bank, at the same time bank also can depend on user. That's why among four relationships in UML, which relationship is best suitable here? Association relationship is best suitable between these two classes, right? So, right, now coming to here, user is interacting with whom here? ATM machine, is it? ATM machine. ATM machine is one more class. You can add some attributes and operations, right? So between user and ATM machine, what is the best suitable relationship? User is depending on ATM machine also depending on user, that's why association relationship. ATM machine, is it, which consists of some part, is it? So functional key is one class, functional key. Keypad is one more class. Keypad is one more class, right? So attributes, operations we can add. So these are three classes. Consider three classes: ATM machine, functional key, keypad. Which one is part of which here? Keypad, functional key and keypads are part of ATM machine. So which relationship you have to use here? Aggregation relationship. If you want to represent small part from the complete class, we have to use aggregation relationship. We have to use aggregation relationship. Coming to bank class, right, which is having there are two classes, savings account, right? Some attributes you can add, withdraw and deposit, right? Current account, right? You can add attributes and attributes, withdraw and deposit operations. Let's consider these three classes: bank, savings account, current account. Which one is parent class here? Bank. What are the child classes? Savings account and current account. If you want to model parent and child classes, which is the best suitable relationship here? Generalization relationship. So this is what the class diagram for an ATM application. We identified set of classes for an ATM application. Then later we had established relationship among them and we added attributes and operations. This is what class diagram for an ATM application, right? When to use class diagram? Useful for forward and reverse engineering. Class diagrams are useful for the abstract modeling and developers they can use for the implementation, right? Next we are going to discuss about sequence diagram. So what's the importance of this sequence diagram? Sequence diagrams were used for modeling the dynamic view of a software system. If you want to model the dynamic view of a software system, then we have to use sequence diagram. That is what the purpose of sequence diagram. What this sequence diagram consists of, that we'll see here. Any sequence diagram which consists of set of objects, dispatching of messages, dispatching of messages among objects, right? Focus of control, lifeline of an object, right? So any sequence diagram consists of set of objects, dispatching of messages among objects, which consists of focus of control. So which can be represented with, focus of control can be represented with rectangle box. So when there is a focus of control, then only operations will take place. Dispatching of messages will take place among objects in sequence diagram. So why the name given sequence diagram here? Dispatching of messages among objects can be taken place in a sequential manner. That's why the name given sequence diagram. That is what the purpose of sequence diagram, right? Lifeline of an object, which can be represented with dotted line. Till this extent only, till from here the object was born, and here the object going to dead. Is it till here object alive? Behind this line the object was dead. This is what lifeline of an object. That's what the importance of sequence diagram. Sequence diagrams were used for modeling the behavior of the multiple objects. So how to model multiple objects behavior by using, so sequence diagrams were used for modeling the behavior of the multiple objects, right? Sequence diagrams model the dynamic aspects of a software system, the emphasis on the sequence of messages rather than relationship between objects, right? Sequence diagram maps the flow of logic, that we will see it anyhow. We are going to model sequence diagram now, right? Right. Draw a sequence diagram. Draw a sequence diagram for an ATM application. For an ATM application. Draw a sequence diagram for an ATM application, right? Any sequence diagram is a collection of objects. So for an ATM application, what might be the objects here? Let's identify. User is one of the object. User is one of the object. How to represent? Underline, right? One more object which we are going to identify is of keypad. Keypad is one more object. One more object, ATM machine. ATM machine. So we identified 3 objects for ATM application, right? So if you give underline, that represents objects. Objects are of 2 types, anonymous object, reference object, right? So if I keep like this, right? So if I add user, this is a reference object. Whereas here, if I don't add anything, this is what an anonymous object. Anonymous object. That is what the difference between anonymous object and a reference object, right? Now, as a user, right, I want to dispatch message from one object to another object. So, as a ATM user, initially going to insert ATM card into the slot. ATM card into the slot, right? Insert ATM card into the slot, right? Once the card is inserted, right? Validate that card. Validate card. If card is valid, what ATM machine will do? ATM machine will ask to the user, enter PIN number. Enter PIN number. Enter PIN number. So what the user will do, with the help of keypad, PIN number was entered. PIN number was entered by whom here? PIN in digits, entered by the user. Once the PIN number was entered, whether the PIN is valid or invalid, supposed to be verified at ATM machine. ATM machine is connecting with bank database, bank server, and verifying it, right? So validate PIN. Validate PIN. Daily, which we are doing daily, right? So daily we are reaching to ATM machine and we are inserting card, and if our card is valid, which will ask us what here, enter PIN number, we are entering the PIN number, is it? So the ATM machine will connect to the bank database, which will verify the entered PIN number is valid, which will ask you what? Select transaction type. Select transaction type. What is sequence number? 6. Select transaction type, right? So we selected the transaction that is for withdraw of amount, right? Is it? We selected withdraw. Then ATM machine will ask to the user that, what ATM machine will ask? Enter amount for withdraw, enter amount. What the user will do here? What the user will do? What user will do? User will enter the amount, right? Amount through keypad, amount in digits, is it? Once the amount was entered by the user, whether the ATM user having sufficient balance or not, check balance. What will take place here? Check balance. ATM machine will connect to the database, checking the balance. If they have sufficient balance, then ATM machine will ask to the user that, is it, do you want receipt? If the user expecting yes, I want receipt, you have to give the message, right? Yes. Then ATM machine will give you what here? Collect money, is it? Collect money and receipt. Collect money and receipt. Then again, after first transaction, is it? ATM machine will ask to the user, do you want to continue? Do you want to continue? If you say, no, I don't want to continue, is it? I don't want to continue, no. Then ATM machine will send a message to the ATM user. What is that? What is that message? Thank you for using our ATM service. Thank you for using our ATM service. Thank you for using our ATM service. So this is how to model sequence diagram for an ATM application. So daily everyone is doing that, right? Reaching to ATM machine, inserting card. If your card is valid, which will ask you PIN number. If PIN is valid, which will ask you to select transaction, and later which will ask you to enter the amount. You enter the amount. If you have sufficient balance verification will take place. If you have sufficient amount, which will ask you to collect the money. Do you want to continue? Next transaction, no. Then which will give you message, thank you for using our ATM service. This is what sequence diagram for an ATM application, right? We had modeled sequence diagram for an ATM application, right? Coming to purpose, the main purpose of this diagram is to represent how different business objects interact. So just now we had discussed it here, just observe. So what is your focus, this rectangle box, focus of control? This dotted line represents lifeline of an object. Till what extent the object is alive? After here the object is dead. That is what the importance of dotted line. Right? So when there is a focus of control, then only the object dispatching of message will take place. That means to say operations among objects will take place. Dispatching of message will take place, right? And these are all the objects, right, which we had discussed, right? And coming to next, when to use sequence diagram. Sequence diagrams can be helpful modeling tool when the dynamic behavior of objects needs to be observed. So we already discussed sequence diagrams for used for modeling the behavior of the multiple objects, not single objects, right? Coming to collaboration diagram. So what is the importance of this collaboration diagram? Collaboration diagrams were used for modeling the structural organization of objects, how the objects were structurally organized. That can be represented by using this collaboration diagram. That is what the purpose of collaboration diagram. So objects, so any collaboration diagram consists of what here? Objects taking part in the interaction, objects organization, structural organization of objects, right? And the purpose of to capture dynamic behavior of a system, to describe structural organization of objects, to describe interaction among objects, contents of a collaboration diagram. What any collaboration diagram consists of? Links, messages, objects, links, messages. Objects, links, messages, right? now we are going to model collaboration diagram for ATM application. Draw a collaboration diagram for an ATM application. For an ATM application. Draw a collaboration diagram for an ATM application. So we already identified what are the objects for an ATM application. So we already identified user is one of the object. User is one of the object which we already identified, right? User is one of the object, right? User is one of the object, right? User is one of the object, right? So keypad is one more object. Keypad is one more object from sequence diagram which we already identified, right? ATM machine is one more object. ATM machine. ATM machine. Right? One more object. So now links among objects can be established in, right, in this collaboration diagram, right? So now user can send forward and reverse messages. Forward message, reverse message. Forward, reverse, forward, reverse, right? Now observe. So initially user is, what user will do? What user will do? Initially user insert card into slot. Once the card is inserted into ATM machine, validation will take place. Validate card. Once the card is a valid card, then ATM machine will ask you to what here? Enter PIN number. ATM machine will ask the user. Enter PIN number. Enter PIN number. Once the ATM machine is asking the user, then user will enter PIN number here. PIN in digits. PIN in digits. PIN in digits. Right? So then once the PIN is entered here, what will take place? Validate PIN. Validate PIN. Once the PIN is valid, ATM machine will ask you what here? ATM machine will ask you enter amount for withdraw, right? And once the ATM machine is asking to enter amount for withdraw, right? So through keypad, the user, what here? Amount in digits can be entered. Amount in digits. Amounts in digits. Once the amount in digits can be done, then whether the ATM holder having sufficient amount in their account or not, check balance will take place. Check balance. If they have sufficient balance, then ATM machine will give a message to the user that collect amount and receipt, right? And ATM machine will ask you, do you want to continue? Do you want to continue? Then the user will say here, user will give message that no. Then ATM machine will give a message that thank you for using our ATM service. Thank you for using our ATM service. So this is what the importance of collaboration diagram. Collaboration diagrams were used for modeling the structural organization of objects, how the objects were structurally organized. That can be represented by using collaboration diagram. So combination of sequence and collaboration diagrams can form an interaction diagram. What is interaction diagram? Interaction diagram is a combination of sequence and collaboration diagram. So combination of sequence and collaboration diagrams, we call them as interaction diagram. Why the name given interaction here? In sequence and collaboration diagrams, the objects will interact. Objects will dispatch messages among them by interacting. That's why the name given combination of sequence and collaboration diagrams, we call them as interaction diagrams. This is about collaboration diagram, right? Next, we are going to discuss about state chart diagram. So what's the importance of this state chart diagram that we'll discuss? State represents here condition. State represents condition. What is state here? State represents condition. So some event occurred, is it? So some operation has performed. That means to say condition is satisfied. Then only transition can trigger from one state to another state. What is the purpose of state chart diagram? State chart diagrams were used for modeling the behavior of the single object. That is what the purpose of state chart diagram. State chart diagrams were used for modeling the behavior of the single object. That is what the purpose of state chart diagram, right? State chart diagram which is used to model the dynamic view of a software system. Just we had discussed all this, right? And we are going to model state chart diagram for ATM application. State chart, what is a state chart diagram for an ATM application? When to use state chart diagram? They are perfectly useful to model behavior, just now we had discussed, right? To model the behavior of the individual object, right? To model the behavior of the individual object. Let's see. So draw a state chart diagram for ATM application. Any state chart diagram consists of collection of states, transition among states. Any state chart diagram will start with initial state which will end with final state, right? So any state chart diagram will start with initial state. ATM user insert card, and after that has to wait for few minutes. Then which will give what here? Select language. Select language. After selecting language, you have to enter PIN. Enter PIN. After entering PIN, PIN is valid, which will ask you enter amount for withdraw. Enter amount. Once you enter the amount, if you have sufficient balance, is it collect cash and receipt. Right? Is it collect cash and receipt, and which reaches to its state here, final state. So this is what state chart diagram. So it's state chart diagrams for used for modeling the behavior of the single object. So when the object is here, is it you inserted the card, is it when some event has occurred, means some operation has performed here, some condition has satisfied, this is state. Then only transition is triggered from which state to which state here, select language. So again some event has occurred, language was selected successfully, some condition has satisfied. That's why transition triggered from select state language to select language state to enter PIN. Again here enter PIN was entered, is it when can the condition will satisfy? The entered PIN supposed to be valid, means condition has satisfied. That's why transition is triggered from enter PIN state to which state here, enter amount. Here the amount was entered and the verification will take place by connecting with banking database. If you have sufficient balance in your account, then the transition is triggered from enter amount to collect cash and receipt. Here the user has successfully collected the cash and receipt. Now the transition can trigger from collect cash and receipt to final state. This is what the importance of state chart diagram for an ATM application. Right? When to use state chart diagram, they are perfectly useful to model the behavior in real-time systems. Right? So that is what the purpose. Coming to component diagram. So what is the importance of component diagram? First of all, what is component represent? Component represents physical aspect of a software system. Physical replaceable part of a software system, we call it as component. Example of components are all executable files, libraries, documents. All these are the example for components, right? So component diagram is for used for modeling the physical aspects of a software system, right? So what is the graphical representation of component? We already discussed it. Now, which we are going to model component diagram for an ATM application. Let's take, draw a component diagram for an ATM application. Draw a component diagram for an ATM application, right? So as a designer, before going to draw component diagram for an ATM application, any component diagram consists of what here? Collection of components, right? Each and every component is supposed to be given unique name and relationships among components. So what might be the components for an ATM application? So ATM user is one of the component. This is what graphical representation of component in UML, user. Database is one more component for an ATM application, right? Database. database, right? And manager is one more component for an ATM application. For banking application, manager will take place here. And here, if any banking system giving problem, who is going to resolve here? Administrator also will become one of the component, administrator. These are all the software components. What are the relationships among these components? So what we had done, we identified components for an ATM application. So 4 components, and we given unique name for each and every component. Now what next we have to do? We have to establish suitable relationship among these components. So any component diagram is a collection of components and relationships among components. That is what component diagram for an ATM application, right? Now user and database, these are 2 components. Which component is depending on which component? User component is depending on database component. Dependency relationship, right? Manager and database. So these are 2 components. Which component is depending on which component here? Manager is a component which is depending on database component. Manager is a component which is depending on database component, right? Similar way here, administrator and database. So administrator is a component which is depending on database component, right? So again, user is depending on manager, is it? So this is what component diagram for an ATM application. So which is helpful for the programmers to implement the software system, to generate source code, right? So component diagram can be described, static implementation, right? Files are the best example for components, libraries, executables, all these are the best example for components, right? And model the components of a system, model database schemas using component diagram, model executables of an application, is it? Model system source code also, right? So any component consists of what are the contents here? Components, interfaces, relationship, just now we had discussed. Coming to deployment diagram. So what is the purpose of deployment diagram in UML? Deployment diagrams were used for modeling the hardware configuration of a system. So what is hardware configuration? Is it? So the components, so far we had discussed components. What are the software components which were built or developed by the developers? Those supposed to be deployed in hardware nodes, hardware servers. That is what deployment diagram, which represents hardware configuration of a system, right? So that is what. So deployment diagrams which represents physical aspects of a system, which consists of nodes. So directed links among nodes. So what is the graphical representation of node in UML? Cubic graphical representation of node in UML. So this is what graphical representation of node, right? So we'll discuss, we'll draw component diagram for an ATM application. Already we draw a deployment diagram. Draw a deployment diagram for an ATM application. Draw a deployment diagram for an ATM application, right? So before going to draw deployment diagram for an ATM application, right? Any deployment diagram consists of collection of nodes and links, is it? Links among nodes, right? Now identify what are the nodes. Node represents what here? Standalone computer, which is having some processing capability, which is having processor, is it clear? Some memory and all, is it? Simply we call it as our laptop, desktop, that can be server systems, all these comes under nodes, right? So any deployment diagram is a collection of nodes. Let's for an ATM application, what might be the nodes here? So this is what? Node, right? So this is node, regional ATM server. ATM server is one of the node. One more node, bank database server. Bank database server. This is also one of the node, bank database server, right? One more node. Here, if the bank manager wants to take the print, one more node supposed to be there, we call it as printer. This is not a node, this is a device. Difference between device and node here is, so which is marked means node, not marked means device, right? So device don't have processing capability, whereas node is having processing capability, CPU, some memory and all. Printer don't have, right, processing capability, right? Again here regional ATM server, which consists of here again subservers, right? this we call it as ATM station 1. Here is ATM station 2 means server 1 sub servers simply. So link can be established among them, connections, right. So this is what the importance of deployment diagram for an ATM application. Deployment diagram for an ATM application. So on these servers, is it, some software components, developed application can be deployed which can run continuously in server, right. And these are the ATM station 1s, mean ATM, is it, ATM station 1, station 2. Through this ATM station, ATM machines, the users can communicate, is it, users can perform their operation, withdraw, deposit and all. So this ATM machine which is connecting with ATM regional server, and the ATM regional server is connecting with database. If manager wants to know at the end of the day what are the transactions performed, so with the help of printer, the transactions details can be taken in the form of printer by the manager, bank manager. That is what the importance of deployment diagram for an ATM application. Deployment diagram for an ATM application, right. Coming to activity diagram. So what's the importance of activity diagram? What's the importance of activity diagram, right? So the importance of activity diagram which is used to model the parallel activities. Is it? If you want to model, as a designer, if you want to model parallel activities, parallel executions, using activity diagram that can be modeled. Activity diagram is similar like a, what here, flow chart, right? So how the activities can be flowing, is it? So that is what the importance of activity diagram. About this we'll discuss. An activity diagram is a type of flow chart with additional support of parallel behavior. So parallel activities will take place. This diagram explains overflow of control. So activity diagram can be modeled with swim lane, without swim lane. So whenever we have parallel activities, then we have to use with swim lanes. Where we don't have parallel activities, then in that case, the designers, they can use without swim lanes. Activity diagrams can be modeled, right? Now, which we are going to model activity diagram for an, draw a activity diagram. Draw an activity diagram. Diagram for an ATM application. Draw an activity diagram for an ATM application, right? Now, with swim lane, which we are going to model activity diagram for an ATM application. So here the in the activity diagram, activities were in activity diagram, activities were application, right? So next, see here, customer is right. So customer is one of the activity. Customer is one of the activity, right? ATM mission, ATM mission, customer, ATM mission, bank database, right? Customer, ATM mission, bank database, right? An activity diagram will start with initial state. This is what the initial state. This is what the initial state. So customer, what the customer is doing here is insert card. If card is valid, which will ask you enter PIN. If card is valid, enter PIN, right? Is it? So whether the PIN is valid PIN or not, supposed to be authorized. Is it? Authorized. Authorize the PIN. Right? if it is a valid pin, if it is an invalid pin, what will happen, that we will see. If it is a valid pin, if it is an invalid pin, if it is an invalid pin, if it is a valid pin, right, what the user has to do here? ATM machine will ask them, enter amount, right, enter amount, right. So, if the user has, customer has entered the amount, right. So, what will take place here? Check balance, check balance. If the user is having sufficient balance, customer is having sufficient balance in their account, right. So, what will happen? If they do not have sufficient balance, what will happen? If balance is greater than or equivalent to amount, what will happen? If balance is less than amount, what will happen? That we will see, right. If the balance is greater than or equivalent to amount, right, in that case, here fork will take place here. What is mean by fork? One incoming transition is gets divided into two outgoing transitions, that we call it as fork, right. So, if the balance is greater than or equivalent to amount, right, the customer can collect money, collect amount, right. At the same time, what will happen here? Debit amount from the account, debit amount from the account, right. Then what will take place here? Just observe. So, that is what we call it as, this we call it as fork. What is mean by fork? One incoming transition gets divided into two outgoing transitions, we call it as fork. Then what is join here? Two incoming transitions going to combine and produce one outgoing transition, we call it as what here? Join. We call it as join, right. This is what we call it as join, right. Once the join, let's see. Right. So, join. Now, so what will happen here? Now, observe here. So, one collect amount, is it clear? Debit amount from the account, right. Here, what will take place here? Right. Show balance, show balance, right. If the balance is less than amount, what will happen here? Balance, is it? Balance will be shown. You have less balance, you have less amount in your account. That is what show balance. From there, is it, due to space complexity, so let's see here. As usual, I am taking three objects here. Customer, continuation. Customer is one object. ATM machine is one more object. ATM machine. Simply, as usual, I am drawing. So, we have less space here. That's what the ATM machine. One more object, second object. Third one is of bank database. Bank database, right? So, show balance. After that, what will take place here? Right? And here eject card. eject card, right? So here uh, if the enter pin is invalid, what will happen here? If the pin which was entered is invalid, what will be see? So card will be ejected. The enter pin is invalid, card will be ejected, and which reaches to where here? Here. Take card. Customer has to, after eject, take card and reaching to which state here? Final state. An activity diagram which started with initial state. This is what initial state. Was it an activity diagram which was started with initial state, which will end with final state? Let's discuss briefly here. Draw an activity diagram for an ATM application. Now observe how many objects grouped into what here? Groups. Customer is one group, ATM machine is one more group, bank database is one more group. So we call them as swim lanes. Swim lane 1. This one we call it as swim lane 1. Swim lane 2. Swim lane 3. Right? So swim lane 1, swim lane 2, swim lane 3. Now observe here. Initially the customer is here with initial state. Inserted card, card was valid. Now enter the pin. Whether the entered pin is a valid pin or not, which can be authorized with bank database authorization. Here condition will take place, the entered pin is valid. If it is invalid, card will be ejected. If it is valid, what will happen here? ATM machine will ask to the you customer that enter amount. Customer has entered the amount, so balance checking will take place at the bank database, right? So the ATM machine is connecting with the bank database, and if the user is not having balance is less than amount, you entered for example here, the amount which you entered for example 10,000, but in your account you have just 5,000. What will happen? Balance 5,000 only. If the condition is it balance is less than amount, what will happen here? So which will what will happen? Which will show you balance. So you have less balance. You have less balance. If balance is greater than amount, you entered for example 10,000. Is it for withdraw? Your balance in your account you have balance is 15,000. No problem. What will happen here? So you will get the collect the amount. So parallel activity will take place here, and as well as debit amount from the account. So this we call it as fork. What is mean by fork? One incoming transition gets divided into two outgoing transitions. We call it as fork. One incoming transition gets divided into two outgoing transitions. We call it as fork, right? Again, two incoming transitions going to join, two incoming transitions going to join, and producing one outgoing transition, we call it as join here. Right? Now here show balance, and again here what here some condition, eject card, take card, reaching to final state. This is what graphical representation of final state in UML, right? And this is what activity diagram is basically a flow chart to represent the flow from one activity to another activity. The activity can be described as an operation of the system, right? The control flow is drawn from one operation to another, right? This flow can be sequential. Just now we had discussed sequential or branched, means some conditions. Is it? If the condition is true, one condition, the decision is having what here? Two branches, right? If the condition is true, has to follow true path. If the condition is false, has to follow false path. That is what branched or concurrent. This distinction is important for distributed systems, right? Activity diagrams deals with all types of flow control by using different elements like fork, join. Just now we had discussed fork and join, right? So what is the purpose of this activity diagram? What is the purpose, right? The contrary to use case diagram, in activity diagram, it is obvious whether actions can perform business use cases together or independently from one another. Activity diagrams allow you to think functionally. So that is what the importance of activity diagram. When to use this activity diagram? What is the situation where activity diagrams can be used by the designers? Activity diagrams are most useful when modeling the parallel behavior of a multi-threaded system. Just now we had saw fork, join, parallel activities taken place here. When you want to model parallel behavior of a multi-threaded system, or when you documenting the logic of a business process, there exactly this activity diagrams required for us. Because it is possible to explicitly desirable parallel events, the activity diagrams as as well suited for the illustration of business processes, since business processes rarely occur in a linear manner and often exhibit parallelism. So if you want to model business process parallelly, then activity diagrams required there. That is what the purpose of activity diagram. This diagram is useful to investigate business requirements at a later stage also. Right? An activity diagram is drawn from a very high level, so it gives high level view of a system. This high level view is mainly for business users or any other persons who is not a technical person. This diagram is used to model the activities which are nothing but business requirements. So the diagram has more impact on business understanding rather than implementation details. So that is what the importance of activity diagram. Thank you.